A lot of the games that you're doing, a lot of them are kind of platformery type things, or at least kind of scrolling games, like R-Type's a scroller. A lot of them are jumpy platformy type games, as things of the era that we're interested in, we're often like that. What else are you going to do? So I've done like a very basic one that just illustrates a couple of the things you would have to do to build a platformer, as opposed to building the kind of asteroid or breakout type thing that we've already looked at. So here's a very simple one where I've created a very simple world, and I've got a little guy. I just stole the braid guy, and he is, and it's the usual controls. I've got A and D here to move him back and forth, and well, isn't that fantastic? Hey, look, I did one clever thing. When he moves left, I'd use the flip trick. So when we're drawing the sprite, you use the X scale -1 to flip him, so he can go the other way. But much is lacking in this version of the game, I think it'd be fair to say. It's pretty poor. But that's okay. But this would be the first thing you would do, right? If you had your player sprite, you'd get him on the screen, get him drawn, and have some code that allows him to move, and he just slides along at some velocity. He can fall off the world if that's what's required, and then he comes back. But it's obvious for this guy that you really want to animate. So first thing to do, if I press magic key number 1, use walk anim. As can you read use walk anim? Is it big enough? Right. So now I've just put in some code that cycles through the animation frames while he moves. And there are ways of doing this that are better and worse. You can do quite fancy ones, you can do really simple ones. I've just hacked in a really simple one where there's kind of just like a constant rate of progression through the animation frames. What I basically do is I just measure how many pixels he's moved along from the kind of start of his walk cycle. And that number, let's say the whole walk cycle is like 50 pixels or something like that. And the idea is that the number of pixels he's gone along that walk cycle is a fraction, and I use that to index into the frames of the animation loop. So you just play the most appropriate frame, and it ends up looking like that. And it's not terrible, right? It's not brilliant, but it almost works. You can see that the foot position is like almost coherent. I didn't try to make it look pixel accurate or anything, and the real games probably get much more subtle stuff going on in it, but it does roughly the right thing, and already it looks a lot better. So that's the really simple way. As I said in one of the lectures, there's a more advanced way of doing this where you actually would have your animator specify, at which horizontal position each frame is relevant, and you would kind of queue them up. But I've just divided them equally and just said, look, he's got a 50 pixel run, and in the first 10 pixels of this frame, and this frame, and this frame, and this frame. Really simple. So at least it's something. It has a couple of, in itself, obvious downsides, including the fact that when I stop, it just stops whatever it was playing in the cycle. So in this case, he's stopping with his legs like separated, like he's supposed to be in the air, which doesn't make a lot of sense. So of course, real platformers, depending on how fancy they are, they have to do various things to try and resolve an animation if you stop it halfway through. Whether they just quickly play it to the end or they just terminate it. The easiest thing to do is to just have a rest pose like that, where you just say that one of the poses is like the neutral one, and if you stop playing the animation in the middle of a walk, you just have a flag saying that he's currently walking when he's pressing A and D, and then when you're not pressing A and D anymore, you say you're not walking, and you just tell it to go back to the base frame. And that just very simply means it stops him doing this thing where he can be hovering in the sky. Now, there's a little bit of a jump there as it jumps from the animation to the rest pose, which you might think is a bit ugly. If you really wanted to, you could smooth that over. You could play like a small transition animation, but I didn't bother. I just did a kind of jump cut to the rest position. So that's okay. Right, so that's that part of it done. The other thing that's sort of conspicuously wrong with this right now, he's not on the ground, because I didn't put gravity on yet. There's a reason for that. So I'll put gravity on now, and he'll fall to the ground. Hooray, triumph. A related thing about that is jumping. Right? So we'll talk about jumping. So basically the way you do jump in a platformer is when you press the up key. It's a bit like thrust on a spaceship. You apply a force to them. In the case of a character jump, instead of thrust, which is a continuous force, obviously in the case of a character jump, it's a one-off, which means technically it's an impulse rather than a force. And it just applies if he happens to be on the ground and he presses the key. This is the problem with perpetual jumping is you have to make sure that you don't just say every time he's pressing the jump key, add something to his velocity, because then he can fly, not jump. So jumps, the thing about a jump is it's kind of flying that you can only do when you're on the ground. So there's just a flag here to check whether he's on the ground. I'll get to the details of that later. But it knows when he's on the ground or not, and if he's on the ground and you press jump, it sets his velocity to some initial launch velocity, and if you're not, it doesn't, and that allows him to jump, like that, right? But I'll show you another little interesting thing that you might see, and that's if I switch, first of all, I'll put the trail back on, and if I do that, I think I can reset it to make it look cleaner, right? So this is just like a ghost trail. I'm just remembering the old positions and drawing them with alpha on them. A useful diagnostic, by the way, if you want to, be able to see if you're working on like jump logic or some animation logic, it might be useful to just remember the last 50 positions and draw them ghosted. So that's what I'm doing here. Right? I'm going to switch gravity off, and that's going to allow me to, of course, now when I jump up, all the jump does is it just puts an arbitrary velocity in them, right? The jump velocity. And then in theory, what normally happens is gravity starts to attenuate it. It'll go down and down and down. It'll go to 0, and then it'll go negative, and it'll come back down. Other way around, in fact, it starts negative, right? Because jumping y goes up, so it starts negative and becomes positive. Doesn't matter. You can do it either way. So if I jump here and there's nothing to stop him, he jumps very high. And then when he falls down, which you should do eventually because I switched it back on, I think. Depends how long I wait. Now I don't rush. I didn't put a display on the screen for the G thing. We're going to have to start again. See, things I won't know now. Right. Oh, God, how long am I going to have to wait? I didn't think it through. There we go. Boom. Okay, that actually didn't show quite as vividly as I would have wished. Let me just try this again. So gravity is on. Switch gravity off. Do that. And we can go up a lot. And then switch gravity on. Yes, good. Did you see it? When he came down, you see what happened? He kind of stalled a little bit. He came down, he's going quite fast, right? I should use the pointer so people can see it in the video. He's coming down, in each frame he's moving quite a large amount because he got a big velocity in him, right? Because he fell from a long way. Jump, big jump, and then he sort of freezes and seems to go slow. So did you actually sort of observe the kind of weird discontinuity? You can see it if you know to look for it. And then he seems to look almost like he parachutes the last little bit of the way. Can anyone say why has that happened? Why did he suddenly have this loss of velocity at the end?
Because you don't want him to go through the floor. Right?
Correct answer, because you don't want him to go through the floor. So it kind of happened as a side effect. What happened was his position was here, and then it was here, and then it was here, and the next one would have been like way down here. He'd have been in the ground. And obviously I don't let that happen. The naive thing to do is if you've done your collision check and he's like way off the ground. So it's like, well, what do? There are a couple of things you can do. The standard thing I do in the event of a collision is I say, what do I say? What's the standard thing I do if there's a collision? Go back to your previous position, because it's safe, right? Because it's where you came from. If you came from there, it was valid. So, and remember, you move one at a time so that the old position can't be blocked, right? So what I do is when I detected that he'd fallen into the world, I just moved him back to where he was. And then I had to do one more thing. It's like if you just move him back to where he was and you don't change his velocity, he'll keep hitting into the ground and bouncing back out of it forever, right? So when you detect the collision, you move him back, and in a real physics system, this is where you'd like apply a force, to prevent the collision from occurring. But in a simple platformer, all you need to do to achieve that is to set the y velocity of the character to 0 again. So that's what I did. So he goes up here, and his y velocity is 0, and then gravity kicks in, and it pulls him back down, and he hits the ground more slowly. But it's kind of annoying because it's kind of bullshit, right? Because, he has a stupid parachute that he shouldn't have. So it turns out in platformer games, what you actually want to do is, what should really have happened is, instead, he goes here. The next step, he shouldn't have been under the ground, but nor should he have been left hovering in the sky. He should have been on the ground. So what you should actually do is have set his Y position to be the ground position, right? Now, there are a couple of ways of doing that. If you've only got one ground level, it's quite easy to do it. You just set the value. But in a real platformer game, you've got lots of platforms. So the ground height depends on where you are on the map. We'll get to that in a second. So what I actually do is, if you detect that he's collided with the platforms or the environment, what I do is I just push him up until he's not collided with it anymore. And that way he comes out of the ground just as much as he needs to. And if he was inside a platform, he'd come out of the platform just as much as he needed to. So what I actually do is, it's really dumb. When I detect the collision, first of all, I set his y velocity to 0 to slow him down. And then I push him up by a couple of pixels and do the collision check again in a tight loop inside one frame. And just keep doing the collision and go up a bit and up a bit until it's not colliding anymore. And that basically just makes him push out of any obstacle he's fallen into until he just gets out of it. And then that's when I stop it. So that's called a push-up. right? And with that facility, if I now do the jump again, let's just switch gravity off so we get the big effect, right? Go up big, then switch gravity on, you'll see that he now just snaps to the ground instead of having his parachute, right? He just hits the ground. And what's happened is he went through the ground and I elevated him back up out of it by just the right amount, and it looks okay. So that's that part working. So now we've got jumps that behave reasonably well, right? And even if he's falling fast, it looks okay. And if he's doing a normal jump, it does the right thing, and it's kind of nice gravity. And also, a lot of platformers, they allow you to move in the air, even though in reality you couldn't really. You know, when you move left and right when you're walking, what's happening? You know, it's equal and opposite reaction, right? You're pushing against the ground, and the reaction force moves you. When you're up in there, you can't do that, except in games you can, because it turns out to be more fun that way. So you can do this thing where you can actually move left and right when you're in the air, just because I didn't prevent it. And a lot of games kind of rely on this. You probably know this, right? You know, the little bit of extra control in the air. And it's bullshit. It means you get a jetpack. But okay, fair enough. That's the way games work. So it lets you do that little steering thing. So that's quite nice. But the other thing a lot of platformers do is they also let you do variable size jumps, which you've probably noticed. So not only in many platformer games, it's not just that you jump to your like natural maximal height. That was me. I held the button down, I held W down, and that's as far as I go, right? But in a lot of games, you can like do a small jump, or I can't do it yet because I haven't switched that part on. There we go. You can do smaller jumps where you can like only wanted to jump up a little bit. So you can just do just be baby jump, baby jump, and then you can do big jump, and you can do a middle-sized jump, and then you can maybe do the smallest jump that I'll let you away with, which is maybe about that size. You just come off the ground, maybe about half height, I guess, right? So variable size jumps can be quite good for, you know, again, judging onto platforms. A lot of platformer games rely on the fact that you can finesse the jump height a little bit. Any ideas as to how that's done? Velocity on? Yeah, so the way you would think it would work would be, obviously what I'm doing, to get the high jump, I'm pressing W for longer, right? And the small jump, I press W for just a little bit. So in some sense, it must be about how long I'm holding the W key down for. So the naive way to do this, and in fact, one of the games that somebody's working on called Jump King seems to be entirely based on this idea, is that you hold the button down for longer, you get a bigger jump, right? But if you just do that the obvious way, the problem is you wouldn't leave the ground until you let go of the jump. It's like pulling back a spring, isn't it? Like if I hold down W and I measure how long you hold it down for, and then when you let it go, now I know how long you held it for, so I know how big a jump to give you, right? But that's not quite what you want in the game. I don't hold W down for a second and then he jumps. He jumps straight away. But it's just that if I keep W down, he jumps higher than if I'd only given it a little tap. So how do I know in advance how long I'm going to hold the key for? I don't.
It removes the decay.
That's part of it, yeah. So it's a weird little trick, and I'm not sure if this is how real games do it, but I think it must be. It's the way I did it when I tried to figure it out. What I do is when you start the jump, you get an initial velocity and you go up. And then, when you let go of the key, I just set the velocity to 0, which is really strange, right? And it's a discontinuity and it shouldn't really work, but what happens is, imagine you go up and I'm giving you like velocity of 10 units up the way, and then gravity comes in and now it's 9 and now it's 8, and then I let go. At that point, I just set the velocity to 0 again. I half it. Sorry, it wasn't 0. I half the velocity. So when you let go of the key, it takes some momentum out of you for some reason. So you go from 8 to 4 all of a sudden. And that's it. Your velocity is lower. You won't go as high. So that's how the jump stops. And you actually, if you know to look for it, you can kind of see it. Like I do a big jump and it goes all the way. I do a small jump. What you're going to see is at some point I let go and he kind of, his velocity just attenuates when I let go. Like that. But it doesn't look terrible. But that's what happens. It's like he sort of instantaneously loses some of his velocity. Like I say, I half the velocity when you let go. You've got to be a little bit careful that you only do this on the upswing. It doesn't apply when you go down, right? If you hold it down forever, no. You've got to do a check whether you're on the way up. But if he's still on the way up of his jump, so he's got upward facing velocity, and you let go of the jump key, then you can attenuate the velocity, and that has the effect of allowing you to decide after the jump has started that you didn't actually want a full height jump after all. So it allows you to kind of chicken out of the full jump. It's a bit like he puts he's got an invisible thruster to let a jetpack move himself left and right. Well, he's also got a brake. And when you let go of the jump, you're basically saying, I didn't want to go full steam. He's put the brakes on and he slows down a little bit. but he still continues to go up because I only half the velocity, and he reaches a different peak and he comes back down, and that gives me very simple variable jumps. The other thing you have to watch out for is that you may or may not want to have multi-jumps, but generally you don't. You don't want to be able to like jump, 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 and like go forever, right? Which might be what you're getting. So again, normally what you do is you detect whether he was on the ground, which is a collision check on the previous frame. If he's on the ground, he can jump. If he's not on the ground, you don't look at the jump key that way. What you do instead is you look for him letting go of the jump key in order to do the release, right? Unless you've got a game where you do want double jump, in which case you just do like a little flag. You know, maybe you say, I want him to be able to do 1 mid-air jump or 2 mid-air jumps, rarely more than that, right? So you just have a little counter. So when he starts his jump, you know, you would say his like, remaining jumps goes from 3 to 2 or something, and every time remaining jumps is positive, you allow him to jump when he does a new, not when he holds the key down, but when he presses it again, when he does release and press. So you can detect that release and press thing, and maybe give him an extra jump boost if you're doing multi-jumps. Okay, so that's that part of it. The other thing I should show you is the environment, I guess. He's got a ground floor here, but it's not just the ground, it's part of a general environment that I'm building. Built-in game editor, because why not, right? So this is me creating blocks to create the platform environment. And guess what? It's just a grid, right? Platform games, this is just a 2D array, just like the breakout array, except that it goes along the whole width of the play area and is a bit more advanced. And the collision detection wasn't just colliding against the ground, as we've seen in some of our simpler stuff, it's actually colliding against the bricks, right? If I put my collision debugger on, you see this is how it works. So this is where the collision array actually begins. I didn't do it right at the start, just for clarity. So these are the cells, and they're either got something in them or they haven't. And this little inner square I'm just using to show whether the collision system was looking at this, so you can see what it did. So right now the thing is, he's nowhere near the collision, he's nowhere near the grid, so none of these cells even have to be checked. So it's like really quick, right? But as he starts to encroach on it, this box around him is his collision footprint, and as his collision footprint starts to overlap with the collision environment, these go green, which means they were included in the check. So the check is basically, you know, you work out the overlap of this bounding box with the collision grid, and you basically get like a top left to bottom right range in the collision grid, and then you just iterate through that, you know, a 2D array, just it's a rectangle within the overall collision grid, and you just go through them and you check them all to see whether they've got anything in them. And just like breakout bricks, you know, 1 or 0, or like a number for different types of platform terrain, and 0 for nothing, right? So you can see he moves along here, and then eventually he'll get close enough to these guys that it'll detect them, and you can see that they go black, and that's because they've detected an actual collision. So he's detected the collision, and that's what pushes him back and stops him being able to keep going. And the rest of it sort of works. I'll take these away for just now so I can jump high enough. Jump up on top of that, jump across over here. So you can kind of see, I'll maybe take the trail off just to make it look a bit cleaner. So you can hopefully see the green indicates the collision cells that we're doing the checks on, and the black ones are the ones that have said, yep, I'm colliding against you and I'm pushing you off. So that's kind of what they do, right? The other thing that happens here is if I keep going, well, you see I've fallen off the world just now, but in most platformer games, well, some platformer games it's fixed screens, and when you fall off one edge, you kind of come on, you know, you come on the left edge of another screen, and it just does screen resets. Some of the games do that, that's fairly easy, but of course a lot of them do scrolling. So let's enable scrolling, and now I can scroll, and it keeps going through this little scrolling world. So one thing you'll notice if you pay attention to games that have got scrolling on them is that even though it's scrolling, it doesn't scroll all the time. Because if it did, your character would be just rigidly in the centre of the frame and everything would scroll around it, which isn't what happens. What happens is you can move until you reach a certain kind of extremity, which I will have to remove that to show you. If you reach a certain extremity, then it starts scrolling. And that extremity is not the very edge of the screen, because if it was, you couldn't kind of see what was in front of you, and it's important to see a little bit ahead so you know how to, you know, if you have to kill something or jump over something. So there's kind of like a window, a sub-window inside the screen, which in this case starts from here and goes to about here, right? So there's this bounding area, and it happens, there's the vertical equivalent of it as well that I can show you if I jump up. See, eventually it will start to scroll vertically as well, if I bothered to implement that, which I think I did. Maybe I didn't. Yeah, I did. Right, okay, there we go. So you can see that there's like basically inside the play area, there's a smaller area which is the scroll zone or whatever you want to call it, right? So what you basically do here to make this work is you've got the real positions of the things in the world. In fact, we call them world positions, right? Which is like the true coordinate system of your game, the world coordinates. And then you have the screen coordinates, which is the version that gets onto you can actually show. So if you're like far across in your map, you might be over in world coordinates, 500 or something like that, because you've scrolled. But if the camera has caught up with you, it just means that the camera is also at 500, so the screen coordinates are 0 again, right? So the position of the camera, you basically you've got like a notional camera, right? Which in this case here is X view and Y view. So this is my theoretical camera, is at 60, minus 193. And the idea is that when you're drawing any frame, you subtract the camera's position from the world position of your object before you draw it. You can actually do it simpler in Canvas. You can just use a translate, which does the same thing, but you might want to think about it more explicitly, in which case you say, I'm actually going to subtract the camera position. Or as I say, you could just say context translate minus camera X minus camera Y, and then everything else would just work anyway, because the magic translations would do it for you. But the other thing you have to do is the question is, when does the camera move, right? Because the point is, when I'm doing this, the camera is not moving. The camera is staying at, okay, now 7193, right? And it's still at 7193, still at 7193, and it'll stay there until the camera coordinates of the character get outside this safe zone. So let's say I said the safe zone somewhere between 20 pixels and 350 pixels or something, whatever I picked. And what you do is you calculate his position relative to the camera, and as long as it's within those safe bounds, you don't do anything. But as soon as he's outside those bounds, that's a bit like a falling off the world situation. It would have been in Asteroids or something. So you correct for that. If it turns out his X position is 10 pixels less than the safe zone, that means you have to scroll the camera back 10 pixels to compensate. And you'll start to see that here, the X view, instead of being 70, will become 25. So that's just, I'm adjusting the camera coordinates, which are actually notionally up here, right? Just to keep him within the frame in a kind of safe box. So do you understand that? It's a little bit tricky the first time you hear it, but if you just think about what it implies, it's like, yeah, he's moving around in the world, and then you think of his camera coordinates relative to the camera, and if they get beyond a certain threshold, then the way to fix it is he has to pull the camera along with him. And when he pulls the camera along with him, that's what scrolling is. Okay? And it just behaves like that. That clear enough? Any questions about this while I'm in that general area?
What happens when he reaches the ends of the world?
So you have to decide what your ends of the world are. Basically, if it's a finite world, there just has to be some additional check where you just treat the absolute end of the map as an additional, an upper limit. Maybe you allow him to walk right up to the edge of the world. Like I think here, it looks like I'm not going to let him walk to the left screen no matter what I do. I seem to be extending my world infinitely to the left. Infinitely. I'm not going to try it. I don't know what's going to happen. So you just have to hack something in there. With a lot of games, you actually can't really reach the right side of the map because the end condition is before that. You get to the flag, and that's before you've reached the end wall. So you just have to decide whether you can let them actually walk up to the very end or whether it scrolls beyond that. Just a little detail you have to figure out. Reasonable question, though.
So for the V-box drawing, it's obvious enough how the tiles appear, but how would you handle, for example, enemies? Because the coordinates of the world become a bit wonky with regards to the screen. For example, if you run past an enemy and the camera goes past them, then his coordinates flip to some negative nonsense.
Yes. This is true. You have to bear these things in mind. So one thing is that what's often done in kind of bigger scale games is that the collision logic takes place entirely in world coordinates. For example, your spatial manager, right? Remember, your spatial manager is covering the whole map. So it's all in world coordinates. So when you actually do the collisions, it's all world-based and everything's consistent that way. The screen coordinates you really just use to figure out when it's time to scroll the camera and to do the offsets when you're drawing things, but it doesn't have much of a logical effect because it really is just a point of view, and point of view doesn't doesn't change reality, right? Sort of a kind of a relativistic thing, right? You just so the fact that because of the scroll offset means that the bad guy's coordinates are now negative is a detail that when you come to render it, you render them with a negative coordinate and it'll get clipped on the screen. But it doesn't really change anything else because his world coordinates will still be positive. They'll be whatever they were, and he registers in the collision system and he goes into whichever collision bucket he belongs in based on his actual coordinates. So it all just works that way. There are some exceptions where some games don't bother to have world coordinates. They just make it all happen in screen space. So instead of you moving through the world, they kind of pull the world towards you. So everything is actually happening within the bounds of screen coordinates. And you can do it that way. And I think it's one of these, I don't have a strong policy as to what's better. In some ways you can say, well, it's simplifying because the coordinates are always within this screen range and you can keep everything safe. But it also means you have this slightly anomalous thing that you have to keep, like, you know, that all your objects, in addition to their natural motion, have got this additional thing where they get sucked into the world whenever a scroll occurs. So, you know, it's like a little baddie here and he's like moving around in a circle or something. But it would also be that you have to move around a circle and then get translated every time you scroll, because the scroll is really a conveyor belt that's pulling the rest of the world underneath you. I generally prefer world coordinates, but if you do decide to use screen coordinates, you can make it work. It's just one of these decisions that you have to make. Okay, so let me just, I have to make sure I don't fuck up the timing here because I don't want to get the review slots to be broken. So the important thing about those is that they start at, is it 10 past or something? It's the first one, yeah, 10 past 2. I maybe shouldn't go on too much longer. There's a bit more I could say here. I did some things to finesse the jumping, to stop them from, I don't know if I'll even worth showing it. It's that there's a thing that you can potentially do if you're doing naive jumping where you can cause them to, if you just do the obvious things where you make somebody move and on a collision you move them back to their old position, you can get things where you try to jump up a tower like this and they actually will get stuck, right? I'll take off the collision and you can see. So what's happened here is I've jumped up and I've moved into the bricks, and because it was a collision position, I've been moved back to my old position, and the result is I'm back to where I was. So I'm floating in space, hugging the wall, right? And it doesn't look very good. Basically the solution for that I used is I separated the X and the Y component so that when you move somebody back, you separately change their X coordinate and their Y coordinate so they've got independent behaviour. And if you do that, you'll see that's called separate collision. When you do that, it means that when he moves back, the problem before is he moves back and he's still trying to go into the wall, so he keeps just stepping into the wall and never coming out. But if you separate the X and the Y part, it means you can you stop him going into the wall, but you don't suppress the vertical component, so gravity kicks in and he falls down, which is what you really want. So if you try and go up the wall, you can't go up. It pushes you out of it, but it doesn't reset your Y velocity, and then gravity kicks in and it lowers you, right? So that's how you do the fact that you can run up against the wall without mounting into it. And then once you've got that right, you can actually do the real, I don't know if you can quite go high enough, you can actually get right up to the top of the wall by, you know, jumping it, like, because in theory you should jump things from a distance like that, right? Or like that. But usually in a game you can jump from right at the side of a thing where it's like your momentum is kind of magically maintained until you get to the top and then you just go over. So that's a little hack that I had to put in to make the jump work. Okay, so that's what I wanted to get done here. Any further questions? Okay, so now I'm going to try and prepare myself to get on to doing the group sessions. So we have an auditor here who's going to help me. So at each time slot there are, let me make sure I've got this written here. Each time, oh, the other thing is, so I think this table is kind of up to date now. Some of you didn't quite fill in all the fields. I'd asked you to fill in your game name and stuff, but some of you didn't. So I've gone through and fleshed it out, and I think they're correct now. I tried a couple of the team number counts weren't right. So you should all be in here, and hopefully don't have to modify this anymore. These are some people that I'm trying to corral into a team, but I'm not sure if it's working yet. And here are your time slots here. So that's going to be the main reference. So at any given time slot, there are two teams. I'll just sort of randomly decide whether me or Otter takes that team, depending on what we feel like. We'll probably alternate it from week to week, and we'll see how you're getting on. And let's just see if we can make this work somehow. So I will stop it there.